Welcome to The Explainer. Today, we are tackling what looks like a classic heavy-duty physics problem. The source for this one is called Solving for Time, a lesson in looking closer. And believe me, that title is a huge clue. We're going to need to look really, really closely.
And there it is. Whoa, that is the famous time dilation formula, straight from Einstein's special theory of relativity. It's the equation that explains how time itself can literally stretch or shrink, all depending on how fast you're moving. It looks pretty intimidating, doesn't it? Like it holds some deep, fundamental secret of the universe.
Okay, so before we can even think about solving this thing, we've got to understand what all these symbols actually mean. Let's meet the key players in this cosmic puzzle. All right, first up is T. Now you can think of T as the time that's passing for you. Right here, standing on the ground, just watching something, like a spaceship fly by. It's your perspective.
Then we have its partner, T0. That's T sub 0. This is the time that the astronaut on board that moving spaceship is experiencing. And here's the mind-bending part at the heart of relativity. T and T0 are not the same.
Of course, none of this really matters unless our spaceship is moving, so that's where V comes in. It's the velocity, or speed. And the faster V gets, the weirder the difference between those two clocks becomes.
And finally, we have the cosmic speed limit, the one that rules everything. C, this speed of light. It's this universal constant that keeps V in check and actually makes this whole time-bending phenomenon possible. Okay, so let's get down to it. We know the players. Our mission, according to the source material, seems crystal clear. We need to rearrange this whole thing to solve for T.
And there it is, spelled out for us. Our goal is to solve for T. So, get ready. It looks like we're going to have to roll up our sleeves and do some serious algebraic gymnastics to get that T all by itself.
So, here's the question for you. How would we even do that? How do we get T alone on one side of the equal sign? I mean, you'd think we'd have to tackle that square root, right? Maybe square both sides. It feels like it's going to be a multi-step process for sure. But wait, our source actually provides the steps. Step 1 is, hang on a second, that's the only step. And it says, the equation is already solved for T. And that brings us to the surprising solution. After all that build-up, getting ready to wrestle with one of the most famous equations in all of physics, the answer turns out to be, well, pretty unexpected. So, there you have it. The grand solution is to do absolutely nothing. We were asked to solve for T, but if we just glance back at the original equation, T was already there, all by itself, the entire time. Our mission was a trick. It was over before it even began. So what's the deal? Was this just some kind of joke? A bad physics problem? Nope, not at all. This is where we get to the real lesson of this whole explainer. What is actually going on here? This is the key. Tucked away at the bottom of our source material was this one little sentence. Generative AI is experimental. And suddenly, it all clicks. This was never a physics lesson. It was a lesson about who or what created the problem in the first place. An AI. So the real takeaway here isn't about time dilation. It's about critical thinking. The AI was told to create a problem that involved solving for T. And it took that command literally. And this fantastic little failure teaches us so much. It shows we should always read the problem carefully, because the answer was staring us in the face the whole time. It proves that the most obvious answer can absolutely be the right one. It's a reminder to be aware of how literal our tools can be, especially AI. And maybe most importantly, we have to question our own assumptions. We saw a complex formula, and we just assumed it had to have a complex solution. And this leads me to a final thought for you to take away. We just spent a few minutes getting all worked up about solving a problem that was already solved, just because it looked difficult. So I'll leave you with this. What problem in your own life are you overcomplicating right now, where the solution might just be hiding in plain sight?